8th graders. We're going to get into section 6.4, and I'm going to teach you in this section how to add and subtract polynomials. We spent a great deal of time in 6.3 learning some background information about degree of a monomial, degree of a polynomial, how to put them in standard form and identify the leading coefficient. We even learned how to classify them. And then, of course, we applied it by plugging in numbers into our polynomial and getting an answer. So we did all of that in section 6.3, and now I'm going to show you in section 6.4 how to add them together. The key is you can only add or subtract like terms. So what in the world is a like term? Well, a like term has same variable, or it could be more than one variable there. I've seen them where there's a couple there. Okay, same variables with same exponents on those variables. Okay, so that's important, that classification. It's more than just having the same variable. You also have to have the same exponent on that variable to be considered like. Okay, let me just show you with letter A what I mean by that, because we're going to add or subtract as it indicates in the problem. Here's letter A. This is what it says. 15m to the third plus 6m to the second plus 2m to the third. Okay, now I'm going to underline your like terms. I'm going to go ahead and point that out to you. Notice that the first term, 15m to the third, and the third term, 2m to the third, both have the same variable and the same exponent on that variable. They both have m to the third. Okay? Now, what you're going to do is you're going to add those together. They are like terms. They can be combined. And so you don't ever change an exponent in addition or subtraction. Addition and subtraction does not change an exponent. Okay, it never, 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 never does. The only way you can change an exponent are those three exponent rules we learned back in 6.2, where you multiply the same bases, you divide the same bases, or you raise a power to another power. That's the only way you can change an exponent. Okay, if it's just simply adding and subtracting, you don't. So what do? Well, what you're doing is you're going to combine the coefficients. So let's say m to the third are apples, and m to the second are oranges, because they're different. M to the third is different from m to the second. So what this problem says, I have 15 apples, and I have 6 oranges, and 2 apples. So how many do I have in all? So this is what I'm trying to get you to understand, is you don't change m to the third. All you do is add or subtract, depending on the sign, the coefficients. That's all you do. So what's 15 plus 2? 17. We have 17 m to the thirds. And then you just drop down the other term. These are not like. You can't add unlike terms together. All you can do is just leave it as it is. And this is your answer. So you combine what you can and drop down what you can't and box it in. Okay? So let's look at letter B. All right, I see two sets of like terms. I see 3x squared and negative 7x squared. So it's telling me to subtract there. What's 3 minus 7? That's right, negative 4. That's how many x squareds I have. I have negative 4x squared. And then here's my other two right here, 5 and 12. What's 5 plus 12? Right, 17. So I combine my like terms together, and I'm done, because I can't add negative 4x squared and 17 together because they are not like terms. 17 doesn't even have a variable on it. So they're not like at all. Remember, like terms, they have to have the same variable and the same exponents on those variables. Okay? All right, let's look at letter C. And looks like I have two separate letters here. I've got y to the 5th, here's another y to the 5th, and here's another y to the 5th. Okay, remember, we're going to keep the y to the 5th, And we're not going to change that. We're just going to add or subtract the coefficients. All right, so let's start with the 0.9. So we got 0.9 minus 0.4. Well, that's 0.5. 0.5 plus 1 is 1.5. So we're going to have 1.5 y to the fifth. Sorry, I made a little boo-boo there. I didn't write the right number. Okay. And so let's rewrite it, 1.5 y to the fifth. So I've already dealt with all of these. And then I have that kind of that lone variable there that doesn't have anything to add to it. You know, x to the fifth is the only one there, so I just drop it down. And I'm done. I can't combine y to the fifth and x to the fifth because they're not like terms. They're not the same variable. So I can't do that. All right? So that becomes my answer. Let's look at letter D. I've got x squared y, x squared y, x squared y. Okay, so they're all three the same thing, x squared y, x squared y, x squared y. So that means they are all like terms, same variable and the same exponents on those variables. So I've got 2 minus 1, well that's 1, and 1 minus 1 is 0. Well, 0 times anything is 0. So I don't have anything left. It all canceled out. Okay? Are you with me so far? I hope you are. All right, let's look at E. We've got s squared and s squared. Those are the only two like terms I see. So we're going to combine 2 plus 3. That's 5s squared. And then we're just going to drop that lone s down. And that's as good as I can get because I can't add 5s squared to s. They're not like terms. There we are again with that term, like terms, okay? I know you're getting tired of me saying that. All right, let's look at the next one. I see here's a z to the fourth, here's a z to the fourth. So what is 4 plus 16? Right, 20. All right. Now let's go back and look at our constant numbers. I got negative 8 and positive 2. What's negative 8 plus 2? Negative 6. You got it. And we're done. So I can't add 20 z to the fourth and negative 6 because they're not like terms. So I got to leave it alone. Just leave it as the binomial it is. Okay? Let's look down here. I've got x to the 8 and here's an x to the 8. So what's 2 minus 1? Right. 1. And then I got some y's. What's 7 y to the 8th minus 1 y to the 8th? Right. Positive 6 y to the 8th. So yeah, anytime you're working with two different terms, they have to be separated by either an addition or a subtraction sign. So if the number's positive, put a plus sign. If the number's negative, put a minus sign. Okay? So there you go. And let's look at our last one. This one looks a little bit harder. Just look at it carefully. We've got b cubed c squared. Also, here's b cubed c squared. And here's b cubed c squared. Hey, they are all like terms. So just add or subtract the coefficients as it indicates. What's 9 plus 5? 14. What's 14 minus 13? Right, 1. So it's 1b cubed c squared. You can write the 1 or, remember, coefficients of 1 you don't have to write. You can just write b cubed c squared. All right, so there's your tutorial on how to write and how to combine like terms during addition and subtraction of polynomials. Please bring your questions to class.